Hi, Dr. Minkan Sun. The first part is introduction. First, the relationship between China's economic growth and industrial structure. Second, China has basically completed the smooth transition of its economy from high-speed development to medium high-speed development. The difference in the industrial structure corresponding to the development stage is a key factor. Third, in the process of economic development, changes in industrial structure play an important role in economic growth. Fourth, we use the VECM Granger causality test method to analyze the panel data of 30 provinces and autonomous regions in China from 2000 to 2019, and comprehensively examine the relationship between industrial structure changes and economic growth.
Now let me introduce our literature review. Structuralism theory believes that changes in industrial structure are the main economic driving force and the reason for the economic difference between developed and developing countries. The theory of industrial economics holds that there are significant differences between productivity and productivity growth rates between different production sectors, and when production factors flows from low productivity industries to industries with high productivity, economic development gains momentum from this. However, structural bonus do not always exist. According to neoclassical economics, there is a law of diminishing marginal output for factors of production, and sustainable economic growth can only rely on the improvement of total factor productivity. In the book, Comparative Research on Industrialization and Economic Growth, the researcher pointed out that the impact of economic structural changes on economic growth varies with the level of development. The industrialization process can be divided into pre-industrialization, mid-industrialization, and so on. During the industrialization phases, economic growth is driven by industrial restructuring and the flow of factors of production, such as skilled workers, from traditional to emerging sectors. But as the industrialization phases shifts to urbanization phase, economic growth is driven by industrial restructuring to total factor productivity. Some researchers summarized modern economic growth as the process of industrialization and urbanization. The source of products and the destination of resources shifted from agriculture to non-agricultural production activities. That is the process of industrialization. The number of urban population has an impact on industrial structure and productivity, and some researchers found that that new urbanization can optimize industrial structure and improve enterprise productivity and effectiveness through selection effect, then realize is economic growth. In other words, there is a positive relationship between new urbanization and economic growth. As we can see from the graph on the left, since the beginning of economic reforms in 1978, the shares of primary sector labor force has declined and the secondary and third sectors had grown steadily, in line with the general characteristics of the structural transformation process documented in the economic transformation literature. Some scholars measure the change of industrial structure in terms of two dimensions: rationalization of industrial structure and upgrading of industrial structure. In terms of the advanced industrial structure, after taking into account the interaction between the structure of secondary and third industries, there are various fluctuation in the industrial structure from 1978 to 2009, showing an upward trend in fluctuation. Some scholars have found that the driving force of economic growth in regions in the industrialization stage is mainly the increase in total factor productivity, while in the urbanization stage, it is the industrial restructuring, and in cities with mid-sized population, the bonus of economic restructuring gradually disappears, and the driving force of economic growth relies on the increase in total factor productivity. China's economic development is characterized by regional nature and uneven economic development. Some scholars have found that industrialization promotes economic growth in the eastern and western regions of China, while hindering economic development in the northeastern region. Advanced industrialization promotes economic growth in the eastern and western regions, while hindering economic development in the northeastern and the central regions. Some scholars believe that in the more developed eastern regions, the main force driving economic growth is the rationalization of industrial structure, while in the central region, which is in the middle of economic growth development, it is mainly the advanced industrial structure that promotes economic growth. From the time dimension, some scholars found that both the evolution of industrial structure, rationalization, and industrial structure advancement had a positive effect on China's economic growth. Although the relationship between industrial structure advancement and economic growth shows a negative effect in some years, in a comprehensive view, the current research on industrial structuring and economic growth is mainly focused on the content from the perspective of factors, and less on the impact of industrial structure on economic growth from both advanced and rationalized industrial structure. And there are large differences in regional economic development in China. Therefore, we will consider the influence of spatial factors on economic growth and use panel data to analyze the influence of industrialization degree, advanced industry structure, and the development degree of third industry on regional economic growth in China.
My name is Si Zhou, and here is my methodology part. After the previous literature review, the next chapter is about methodology, which mainly includes variable selection and description, data sources, model establishment, and other contents. In order to comprehensively analyze the relationship between industrial structure and economic growth in China, this paper uses the panel data of 30 provinces in China from 2000 to 2019, with a total of 5 variables. Considering the availability of data, we selected data from 30 provinces, excluding Tibet, Hong Kong, Macau, and Taiwan. At the same time, we selected a total of 5 variables, as shown in the table below, including real GDP based on 1990, share of secondary sector value added, ratio of added value of tertiary industrial to added value of secondary industrial, output value of tertiary industrial, and energy consumption. Their abbreviation are shown below. The next is a detailed description of variables, including how they are calculated and where they come from. GDP can be used as an indicator of economic development, and to reduce the impact of the price level, real GDP is converted from 1990 data. The data can be obtained directly from the database of China National Bureau of Statistics. DECY is used to express the degree of industrialization, and the formula is the added value of the secondary industrial to the added value of three industrial, which can be calculated by using the data obtained in the database of China National Bureau of Statistics. SE refers to the ratio of the added value of tertiary industrial to the added value of secondary industrial, which is used to indicate the degree of advanced industrial structure. The output value of the tertiary industrial is used to indicate the development of the tertiary industrial. MY includes consumption of various fossil fuels in the provinces, as well as some fuel imports and non-energy fossil fuels in energy processing and conversion. Real GDP is the independent variable, and the other four variables are independent variables. As shown in the table, we can find that the standard deviation of the three variables of real GDP, T and MY are large, indicating that the values of these three variables vary greatly from province to province. However, the standard deviation of DECY and SE is small, indicating that the inter-provincial data of these two indicators are relatively stable with little difference between each other. The next step is to build the model. Since GDP, SE, T, and MY are relatively large in value, they are logarithmic processed and expressed as ln GDP, ln SE, and ln MY respectively. Since the next step is to build a model, we decide to establish a VAR model to investigate the relationship between GDP and industrial structure, as shown below. In this model, P is the regression lag length automatically determined by SIC and is set equal to 4. Next part is the empirical analysis.
Hello Prof, here is Zhang Yu from Group 12, and I will introduce an empirical analysis expert to you. According to the paper we use granger quality test to analyze the relationship between the industry structure adjustment and economic growth. And the theory behind this research is the second sector's and the third sector's output value and the ratio of the third sectors to second sectors. These indicators probably are driving factors of economic growth. Through the unilateral test, VECM model analysis, variance decomposition, and the granger quality test, we try to use this way to analyze the relationship behind this. According to the result from the table, we can see that the LLC, ATF, and PP tests p-value of the LNGDP, LNT, and LNY are lower than 1%, reject the null hypothesis. The DEC-wise p-value lower than 1%, except the ATF test. ATF test result shows the p-value is 0.029, so still stable at 5% significant level. And the LNSE is different because its ATF and LLC test both are stable at 5% level, but the PP test result did not through the test. P-value is 0.83, higher than 5%, but we considered that the result of the other two tests is both stable, so we think the data is still stable at I0 this level. The next one is the VECM model results. From the result table shows the relationship between the economic growth and the industrial restructuring. Just have one co-integration equation. From the model 1, we can see that the national real GDP is disturbed and deviated from the long-term equilibrium. It will converge to equilibrium through changes in the structure of the secondary and the third sector, adjusting at a rate of 0.0139. According to the Model 2, when the energy consumption is deviates from the equilibrium, it will convert to the long-run equilibrium through the changes in the economic growth, the third sector, and the energy consumption at a rate of 0.0054. And according to the Model 4, shows the third industry will convert to long-term equilibrium through the changes in the economic and the second sector at a rate of 0.0198. The next one is the optimal lag test. We choose these two ways to test the optimal lag for our VECM model. The lag exclusion test and the lag criteria test both are used to check the number of the lag term in the VER and VECM model, and the null hypothesis is contain a lag term of some order. We can see that there are 3 star symbols are in the lag 4 in the table above, and in the table below, at the lag 5, almost all data's p-value exceeds the 1% significant level. After combining these two results, we think lag 4 is the optimal choice for our model. The last one is Granger quality test. We're using the result of Granger quality test to in the VER and the VECM model to respectively to test the relationship between economic growth and the industry structure adjusting, especially in the third sector. The Granger quality test is defined as rely on the variance of the biased least square prediction using all information at some point in the past. So, Granger quality test between two economic variables like x and y is defined as if the prediction of variable y is better than the prediction of y by past information of y alone. Like variable x helps to explain the future changes of variable y, then variable x is considered to be the Granger cause of variable y. So the null hypothesis of Granger quality is there is no correlative relationship between variable x and variable y. So according to the p-value, The results are seen in the long term and the short term in our research.
Thanks, Yu Zhang. I'm Xu Qin. Let's introduce the conclusion. First, the data series of all analyzed variables in this study are stationary and have no unit root. Second, there is a long-term equilibrium relationship between China's tertiary industry, the proportion of secondary industry, energy consumption, industrial structure advancement, and economic growth. Once the relationship is destroyed, these variables will be returned to long-run equilibrium in the short run. Third, China's tertiary industry, the proportion of secondary industry, energy consumption, industrial structure advancement, and economic growth affect each other. These effects show different degrees and ways. Fourth, from a long-term and short-term perspective, economic growth, the proportion of secondary industry, and industrial structure advancement all have bi-directional causal relationships with each other, and with tertiary industry and energy consumption respectively, while there is no causal relationship between energy consumption and tertiary industry. Next part is policy implications. First, the government should balance the relationship between the secondary industry and the tertiary industry, choose the leading industry reasonably, make full use of fiscal tax, financial, price, and other means, introduce industrial and land support policies, and properly solve the problem of restructuring the original backward industries. Second, the government should make long-term plans, clarify the property rights system, improve market supervision, and ensure orderly market competition. Third, the government should improve relevant laws and regulations, supervise the market in accordance with the law, and continuously optimize the market-oriented mechanism and investment environment. Fourth, the government should improve the functions of the public management department, establish a specialized agency for transformation, and manage the transformation and upgrading of the industrial structure. Next, we should weigh the economic growth caused by the processing and manufacturing industries. The stock of natural resources varies with development, production increase, stabilization, and decline. We recommend focusing more on reducing energy consumption. The choice of the leading industry must be conducive to bringing the lock-in effect of resources, systems, and technologies on the urban industrial structure, solving or alleviating the basic contradictions of urban economic development at the current stage, adjusting the layout of productive forces and promoting the coordinated development of the urban economy, and improving the level of economic development, increasing competitiveness. The last, growth-oriented cities should rationally plan their layout, vigorously cultivate strategic emerging industries, and promote diversified development strategies. They should develop scientifically, reasonably determine the intensity of resource development, and strictly evaluate environmental impacts. They should focus on developing the tertiary industry and promote the optimization of industrial structure. Mature cities should make effective use of external spillover effects, introduce external resources, and promote the transformation and upgrading of their industrial structure through the introduction of capital, technology, and management experience. They should vigorously develop the tertiary industry and optimize the industrial structure. Regenerative cities should comprehensively transform traditional industries and actively incubate strategic emerging industries. They should actively develop tertiary industries and rapidly promote the development of modern service industries.